All right, so now we're going to look at algebraic equations that also has times and divide in it. Not fractions, just times and divide. So we are doing equations that also has times and divide. Right, so let me give you an example here. So we're going to start still with linear. So we're still here with linear equations. So we're not going to do factorizing yet. Right. So let's say 3x plus 5 equals 12. Okay, I've chosen something on purpose where your answer is going to be a fraction because I don't want you to be scared of fractions. You've got to get used to them. Okay, so we're busy with equations, which means our question is solve for x. Solve for x. There is an equal in our sum that we've been given, which means we need to throw things over to get the x by itself. So like here we've got linear equations, so there's no exponent, and we need to get x by itself. So let's have a look. First we're looking at our terms. We've got x's and we've got stuff without x's, right? So we need to get the x's alone, so this 5 is going to go over to the other side. So we write what we have, 3x. And we didn't move anything this side, so that's it. Equals, we write what we have. Now we move, so the plus becomes minus. Okay. So we can work this out because it's like terms, so we can plus and minus that. So 12 minus 5 is going to be 7. Okay, now what does this mean here? If we have 3 times x, our answer is 3x, which means this is a times. So what's the opposite of a times? Opposite of times is divide. They go together. So here we're going to say, to get rid of the times, we're going to divide and divide. So those two cancel out, and we have x equals 3 over 7, and that is my answer. Okay, let's do another one. I just quickly want to tell you that of course there's different ways of writing it down. So in the next video I'm going to use a slightly different way of writing it down, just so that if you, you pick how you want to write it down. The important thing is that you get used to the way that you're doing it, and you always do it in the same way. Okay. Right, so that's our sum here, and now we're going to say this is solve for x, there's an equal in our sum, so we have two sides. We're going to look at what is the same. That one is the same as that one, so this one's going to have to move here, That one is the same as that one, and they're going to have to move there. Okay, so now we know how it's going to move. So let's write down. First we write down what we have. We have a 4x. Now we're moving this one over, so it becomes minus 9x. Our equals goes on the line. Here we have a 10. We're moving the minus 3, so it becomes plus 3. So let's work it out. 4x minus 9 is minus 5x. And on this side, we've got 10 plus 3 is 13. Okay, so in the previous one, I made like this and put it over, but you can also just go like this. This is times on this side, so if we take it away, we have to divide on this side. I'm giving myself enough space to write with these arrows. So it needs to be divide on that side. So you can write it like this as well. Doesn't matter, whichever you like suits your brain better. Then that one is gone. So we've got an x equals 13 over 5. But this minus, we don't like minuses at the bottom in maths. It's just a small little thing. Nobody ever does it. It's not wrong, but we don't like it. So we rather write the minus at the top because it doesn't matter where we put it. If we go minus 13 over 5, it's the same thing if we say minus 13 over 5 or 13 over minus 5. It all means exactly the same thing. But for some reason in maths we just don't like that. Because we want everyone to be used to, we normally check for it at the bottom. Oh, so that we never go look for it at the bottom. The thing we see first is this thing or what's at the top. So that's where we keep it normally. So that you don't accidentally miss it if it's somewhere that you're not used to. So if you write it the minus at the bottom, you won't get the answer wrong. But I want you to get used to the kind of conventions in maths, things that we normally do. Also, just if things always look the same, your brain doesn't get confused. Right, now that was basically some things with multiplication and plus and minus. Now let's add a divide in there, a fraction. I'll put all the hardcore, complicated fractions in a different video, so let's just do some easier ones for now. Alright, so now, remember what I said here? Make yourself notes. We're looking at which terms go together. So, here, both of these two is together with this 5, which means this is one term. Which means we can't take one of these ones away. If it's one term, we have to start by getting rid of the things like divides or, sorry, my battery's dying. There we go. So we have to start getting rid of things that's the furthest away from the x. So here, we're going to have to get rid of the divide first. So, getting rid of a fraction or a divide, we're going to take this one, and it's divide on this side. So what's the opposite of divide? The opposite of divide is times. So we're going to move it to that side, and we're going to make it times. Okay. So we've got, what have we got left over? Here we have 2x plus 4. That one's gone. Here we've got 9 times 5. Okay, so 2 plus 4, we can't do anything there. They're not like terms. What's 9 times 5? Just a quick side note, if these kind of things get you frazzled in the exam and you're like, oh, 9 times 5, what's my 9 times table again? Just use your calculator. If you can't use a calculator, I'm so sorry. But if you can, don't feel stupid. Do like little calculations on your calculator, because we don't want you to lose marks because of, you know, primary school maths. So 9 times 5 is 45. Okay, so now we've got this one. So we see what terms have we got? We've got an x and we've got numbers. So that one goes to the other side. So we have 2x equals, and we've got a 45. We're moving a 4, so it becomes negative. So 2x equals 41. And now we take over this 2. I personally like writing it like this. So now our 2's are gone, and we've got x equals 41 over 2. Right. Then I think I'm going to break this one up into a couple of videos so that we can, you know, not get tired brains. But let's do one more of these ones. But obviously slightly more complicated, slightly more complicated. The important thing is, as it's slightly more complicated, don't go, yeah, my brain hurts. Just look at it and go, okay, I need to follow the rules. What's step 1? What's step 2? What's step 3? And just look at what you've got, look at what they're asking you, and follow the rules. Nice thing about maths is that the rules never change. Not like language, which is a complete and utter mess, where the rules just do whatever they want. Alright, I'm going to leave it like that for now. And then we'll do one more that's got an x on the other side. So let's look. Solve for x. There's an equation. There's an equal in my sum. So I've got 2 sides I'm going to work on. So now I said we need to find our terms. So this whole thing is one term. It's all bound together by that divide. This is a loose term. And that one is all by itself. So we take the loose things, the things that's the furthest away from this x first. So we take that one over to the other side. So what do we have left here? 2x plus 3 over 4. We didn't change that at all. Here we write what we have, and we write what we moved. We change the sign, so now it's a plus. If you want to just do this in your head, you can, but I suggest first practice a lot without doing it in your head, so that you don't accidentally make mistakes in your exam. Okay, so we added that together. Now, this is one thing bound together by this divide. So we want to break it up. So we want to get rid of the divide. That's the thing that we don't like here. So we're going to take that over to the other side, and a divide becomes a times. Okay, so here we have 2x plus 3, and we just got rid of that, equals 3 times 4 is 12. Okay, what I just quickly want to mention here, when you as soon as you write that down there, just cross this one out. So all of these little notes that you do, you can do in pencil or with highlighters or in a different color. What I really suggest is to get one of these cool pens that's got different colors. So you can write your whole exam in your blue, and then all your notes you can make in the red. No, you're never allowed to use red. Sorry. Pencil. This one's a pencil. Or in black or in a different color. So then you don't have to switch pens the whole time and get confused. Okay, now we've got a 3, and we've got an x, and we've got a 12. So this needs to go over to that side. So what do we have? That's what we have. On this side, we have 12. We're taking it over, and it becomes minus 3. So we've got 2x equals 9. So now we want to get rid of the 2. So here it is times, so I need to divide, because that's the opposite. So now my answer is x equals 9 over 2. Okay. Important thing, follow the rules. We want to see which terms goes together, and the looser things goes over first. If we take things over, minus becomes plus, plus becomes minus, divide becomes times, times becomes divide. Right. I'm going to do one more. You are more than welcome to play the video on extra speed, if you like, changing the playback speed. If you are going like, yeah, okay, I get this now, but she's talking so slowly and explaining every step, then please play the video fast and laugh at me. You're welcome. Right, now let's say let's make this a 5x. Okay. Right, there's our sum. We have solve for x. We have an equation, so there's an equals, which means we're working on two sides. We have, this is one term, because it's bound together here by the divide. Here we've got numbers, and let's circle them as well. And then we've got an x all by itself. So what do we want to do? We want to take over the loose one first. So we have 2x plus 7 divided by 3. And let's also take this one over, because remember we want all the x's together on one side. So let's move this one over as well. Here it's a positive, so here it's going to be negative. But it can't become part of this, because this is all bound together by the divide by 3. But this one isn't, so it's just all by itself for now. This side, we have a plus 4. We're moving this over, so it's minus 4. Okay, so what have we got here now? 2x plus 7 divided by 3. One thing together. Minus 5x equals 0. Don't second guess yourself, it is a 0. Now, we want to get rid of this 3. It is a divide, so I want to times it. And this is why I wanted to add more stuff on the other side. Because if we times this, these in the past, with all the other sums we had only this and only something on the other side. But here we've got three things. We've got this term, and we've got this term, and we've got this term. So this 3 must be times by each one of them. So we're going to say times 3 and times 3. The reason why we're getting rid, or the reason why this one falls away, is because we're actually also saying times 3 here. I just didn't write it because I don't want you to get confused with, what's the 3 doing there? Because times 3 divided by 3 cancels each other out, and then they're gone. And that's what we want. The important thing is that we remember it to times the 3 with every single term, not just on the other side. If we've got more terms, every term needs to be times by that 3. So here we have 2x plus 7. Let me move it up a bit, sorry, space. 2x plus 7. And then we've got minus 5x times 3. So it's minus 3 times 5 is 15, and the x stays the same. Equals 0 times 3 stays 0. Now what we do is we look at this. Here we've got like terms. This one doesn't have an x, so I want to throw it over to the other side. So 2 minus 15 is minus 13. Alright, and on this side we had a 0. We moved this one over, so it becomes minus 7. You can write 0 minus 7, but 0 minus 7 is just minus 7. And then we want to get rid of this 13. So divide by minus 13, divide by minus 13. And our answer is x equals 7 divided by 13. And that is our answer. All right. So it's very important that you go practice these things. If you need some exercise, I know you've got tons of exercises from school and in your textbooks that you can try. You're more than welcome to send me an email as well. Then I can send you some exercises. But please, if you're practicing, remember your arrows, remember your like terms, and all of these things. And now all of these ones we've done were linear equations. And then making notes for yourself. It's really going to help in the exam to keep your brain from getting too dear mekaar and too busy. Right, hope that helped. Bye.